I'm Wilson Sansbury.
And I'm Aaron Rodgers. Albert Einstein once said, "To raise new questions, new possibilities, to regard old problems from a new angle requires creative imagination and marks real advance in science." A company called Nth Degree Technologies, which is based out of Arizona, is a research and manufacturing company filled with extremely creative and intuitive scientists, engineers, and manufacturing personnel who have made printed semiconductors not just a dream, but a reality. Nth Degree has sparked a new printing revolution by turning the printing press into a 3D manufacturing instrument used to create the world's only fully functional printed semiconductor products. The concept of printed semiconductors is the base technology for all their products, which include printed solid-state lighting and printed photovoltaics. The next generation of Nth Degree products are already in development and are extremely revolutionary. For our project, we are designing a package for Nth Degree's new light bulb.
One of the primary goals for a packaging design is to ensure that the product will have great shelf presence and stand out amongst its competitors. If you browse the light bulb section of any local big box hardware store such as Lowe's or Home Depot, you'll notice that the shelves are crowded with hundreds of light bulb choices that could easily overwhelm the average consumer, causing them to simply choose the first bulb that they can find that matches their specifications, regardless of brand.
Here's both a side and top profile view of Nth Degree's light bulb. You see on the side profile, we could build some type of rectangular base to lock the light bulb into, but this leaves the top exposed. Though it does leave it exposed for the consumer to see, it doesn't provide any sort of structural support. So what we could do is implement some type of paperboard insert that would go between the gaps in these bands of the bulb that would provide support and protect them from being bent or flexed during the shipping process.
Here's our first design. We used paperboard base to lock the light bulb into place. And then the upper portion could be made of paperboard but have large rectangular windows cut into it, or it might be made of like a clear, rigid plastic. But if we use paperboard for the upper with large windows cut into it, it might compromise the strength of the box. So in that case, we could use these paperboard inserts that would go between the bands of the light bulb. They would be triangular shaped with a fold down the center and be placed between the bands to provide additional structural support. Here's our second design based on the top profile of the light bulb. This is just an initial design of what led us to this. This can be constructed from two rectangular pieces of paperboard wrapped around a cylinder about the same diameter of the light bulb and then glued together at the seam. And then the upper one would then slide over the lower one, and they could be glued together in the overlap. And this still gives us a large window to view the product. And it's also symmetrical, so that the consumer has a really good view of the product. We could seal the top and bottom pieces of the tube with two pieces of paperboard cut to fit. And Aaron and I have been talking about designing some type of pull tab system for the top so that the container can be opened. Or possibly designing a twist lock system where you twist each piece in an opposite direction to open the container here at the middle at this overlap seam. And here's a rough sketch of a point of purchase display. It will be modeled directly after the packaging of the light bulb. We were considering placing a kind of a light fixture at the top of the package and the roof of it, over the top of the point of purchase display, so that the contents would be illuminated by the display. We could put 1 or 2 sockets for the bulbs, possibly in 3 sockets in the top of the point of purchase display.